Hi there everybody, this is Bruce, and welcome to our last lesson in this series on the introduction to electric current. Over the past 7 lessons, I have introduced a number of key concepts to you. And what I want to do in this lesson is to make sure that you know and understand everything that I've taught you so far. We will revise these key concepts, and then we will try a fun quiz just to make sure that everything you have learnt is absolutely sound in your knowledge. By the end of this lesson, you should be able to define electric current and use the equation Q is equal to I times T. What is an electric current? Electric current is the rate of flow of charge through a conductor. Let me demonstrate by looking at our circuit board again. An electric circuit provides an unbroken path for an electric current. Any break anywhere in the circuit will stop the electric current passing through the circuit. Watch what happens when I open the switch. When the switch is opened, a break occurred in the circuit and the charge could not flow. When I close the switch again, the circuit is re-established and the charge can flow all the way around the circuit. Conventional current is the flow of positive electric charge from the positive terminal of the battery all the way around the circuit to the negative terminal of the battery. We also use conventional direction when marking currents on circuit diagrams. Conventional current flows from positive to negative. Can you remember how charge passes through a circuit? Well, let's look at the metallic bond theory, which explains how copper conducts electrical charge. A copper wire consists of many millions of copper atoms packed closely together. This arrangement of atoms is called a lattice. The innermost electrons are held tightly to the individual atoms, but each copper atom has 1 or 2 outermost or valence electrons which are held rather loosely. These valence electrons can break free from the atoms. They can move around freely within the metal. The electrons are negatively charged, so when an atom loses an electron, it is left with an excess positive charge. The atom is now called a cation. So inside copper wire, there's a lattice of cations surrounded by free electrons. The free electrons move randomly from one cation to another throughout the lattice. So what happens when I connect a length of copper wire between the positive and the negative terminals of a battery? Can you see that I've connected my short length of copper wire between these 2 points in the circuit? When the switch is closed, the bulb lights up immediately because charge is flowing and there's an electric current. This happens because as soon as the battery is connected in the circuit, electrons are pushed away from the negative end of the conductor and attracted to the positive end. All free electrons in every part of the circuit experience the same force and they begin to move simultaneously. In metals, electric current is the movement of electrons, which you already know are negatively charged. Solutions of ionic salts, for example copper chloride and water, can conduct electricity. The current in a salt solution is created by the movement of positive and negative ions through the solution. Materials that allow the flow of electric charge through them are known as conductors. Metals such as gold, copper and aluminium are all good conductors of electrical current. But substances like rubber, wood and plastic do not allow electric current to pass through them at all. Graphite, which is a non-metal, is an extremely good conductor of electrical charge. The substances that do not allow electrical charge to pass through are known as insulators. Insulators have an extremely high resistance to the flow of electrical charge. The current depends on the amount of charge that moves past a point in a circuit. The current depends on the rate at which the charge moves past that point. When a greater amount of charge is able to pass through a point in a conductor per second, the current will increase. But what exactly is needed for charge to flow? In our electric circuit, we need a source of electrical energy for electrical charge to flow through the circuit. Without the source of electrical energy, no work is done, and electrical energy cannot be transferred to other forms. So can you see that the battery provides a source of electrical energy to allow electrical charge to flow through the circuit? The cell within the battery acts as a source of charge which is able to transfer its energy to a light bulb and able to flow through the circuit as well. Therefore, we can say that the function of the cell is to energize the electrical charge that passes through it. This means that an electric current can only be maintained in a closed circuit. Therefore, to maintain an electrical current in a conductor, the following is needed: a source of electrical energy which provides energized charge, and a closed circuit which provides a continuous path for charge to flow along. I have already explained to you the link between current, charge, and time. If you know any two of these, you can work out the last one by using the formula Q is equal to I times T. Q stands for charge, which we measure in coulombs. I stands for current, which we measure in amperes. And T stands for time, which we measure in seconds. Now that we have revised some of the key concepts, let's try our quiz. Let me explain how it's going to work. I will read a question out to you. You will have a few seconds to think about the answer, and then we will look at the answer together. Right, everybody, here is our first question in the quiz. I want you to fill in the missing word. When two negative charges are brought closer together, they will A, repel, B, attract, C, cancel, or D, ground each other. Of course, the answer is A. Like charges will repel each other. Do you remember in lesson 1 our experiment using the electroscope? We know that the electroscope is charged because the gold leaf is sticking out sideways. It is being repelled from the vertical metal plate. Again, I want you to fill in the missing word. Charge A increases, B grows, C is not lost, or D is used up as it passes through a circuit. I'm going to give you a small hint. Have a look at this animated model. The answer is C. At no stage will charge ever be lost as it passes through an electrical circuit. 4,5 amperes is the same as saying A, 0,45 coulombs per second, B, 4,5 coulombs per second, C, 450 coulombs per second, or D, 4,500 coulombs per second. The answer here is B. 4,5 amperes is the same as 4,5 coulombs per second. It's important to note that the unit, the ampere, which measures current, is exactly the same as the unit coulomb per second. We get this from our equation Q is equal to I times T. Let's now look at some examples of using Q is equal to I times T. How much charge passes through a light bulb in 4 seconds when the current is 3,5 amperes? Will the answer be A, 3,5 coulombs, B, 4,0 coulombs, C, 7,0 coulombs, or D, 14 coulombs? The answer here is D. Let's do the calculation together and I'll show you why. Right, let's write down the information that we've been given. Current is 3,5 amperes and the time is 4 seconds. Let's take our equation Q is equal to I times T, substitute in our values 3,5 amperes multiplied by 4 seconds, and our answer works out to be 14 coulombs, which you can see corresponds to the letter D. Question number 6. How long does it take for 24 coulombs of charge to pass a point in a circuit when the current is 12 amperes? Will the answer be A, 0,5 seconds, B, 1 second, C, 2 seconds, or D, 288 seconds? Let's check your answer and see what you got. Again, I'll write down my information. Q, my charge, is equal to 24 coulombs. The current I is equal to 12 amperes. Writing down my equation, Q is equal to I times T, I will now make T the subject of the formula, so T is equal to Q, the charge, divided by I, the current. Substitute in 24 coulombs divided by 12 amperes gives us an answer of 2 seconds, which corresponds nicely with option C. 2,400 coulombs of charge passes through the ammeter in 2 minutes. What current passes through it? A, 2,400 amperes, B, 1,200 amperes, C, 20 amperes, or D, 2 amperes. Right, let's do our calculation. Q is equal to 2,400 coulombs. Time is equal to 2 minutes. Remember, we must convert to seconds, so 2 minutes becomes 120 seconds. We write down our equation, Q is equal to I times T. We need to make I, the current, the subject of the formula, so I is equal to Q divided by T. Substitute in our values for Q of 2,400 coulombs, time at 120 seconds, and the current I works out to be 20 amperes, which corresponds to option C. Well, I hope you've enjoyed doing this quiz with me. Please join me for our next series, and until then, goodbye for now.